On to Chapter 13, Solutions. Solutions in chemistry are not just answers to problems. What is a solution? I feel like how did that happen? There we go, solutions. We're just going to skip 13.1. I don't remember why, but I'm pretty sure I had a good reason. 13.2, solutions. Solutions in chemistry are homogeneous mixtures. Homogeneous means they're mixing the same throughout. It's a mixture. We have two or more substances, and those substances can be in varying amounts. Remember that mixtures are different than compounds. Solutions are very, very common. Most of the liquids and gases that we encounter in everyday life are homogeneous mixtures. They're actually solutions and not pure substances. The ocean. The ocean covers a large part of our planet. It is a solution of salts and other solids dissolved in water. Blood plasma. That's blood without the blood cells. Blood plasma is a solution. It's got several solids dissolved in it and some gases all dissolved in water. You can have solutions that are any combination of the three physical states. You can have a gas and a liquid and another liquid, etc. Any of the combinations are possible. And here's a table showing you some of these different combinations. A solution being a mixture of two gases, air is a good example of this. Air is mostly oxygen and nitrogen, but there's some other gases there as well. Liquid solutions will have a liquid as the solvent and a gas, a liquid, or a solid dissolved in that. So seawater is an example of solids dissolved in a liquid. Soda or carbonated water is an example of a gas, carbon dioxide dissolved in water. We can also have solutions of two or more solids. And these are alloys. Metal alloys are mixtures of metals. They're homogeneous mixtures. You take an alloy like pewter and you cut it in half, and it's the same throughout. There aren't little chunks of lead or copper or whatever metals are in it. Brass is a mixture of copper and zinc. So any of the combinations are possible. There are two main components in a solution. There's always a solvent and a solute. You can have more than one solute, but there's always just one solvent. The solvent is the majority component, the one that there's more of. So solvent is the majority compound. And then the minority component is the solute. So the solute is dissolved in the solvent. If it's a solid liquid solution, the liquid is usually considered the solvent. We were just talking about water and how it's a good solvent because it's polar. It is such a common solvent that we have a special name for solutions in which water is the solvent, and we call these aqueous solutions. An aqueous solution has water as the solvent. But there are other solvents, things like alcohols, ethers, a lot of organic compounds can be solvents. You could use oil as a solvent. In order to make a solution, the solute and the solvent have to be able to mix together. So you can't make a solution out of oil and water because the oil and water will not mix. And we've talked about intermolecular forces now, so we understand why that is. This idea is important, like dissolves like. We need different solvents because different solutes require different things. Polar solvents are great for polar solutes, and nonpolar solvents are needed for nonpolar solutes. So if you have a solvent like water Acetone, that's fingernail polish remover. Methyl alcohol, also called wood alcohol. These are good polar solvents, and these will dissolve polar molecules. Sugar is polar, ionic compounds are polar. These are common non-polar solvents. Hexane, I believe that's the solvent in rubber cement, diethyl ether, toluene. These tend to be much more volatile, and they tend to have an odor to them. And you know, when I think of solvents, just in an everyday term, I think of those cans of stinky things in the garage, right? Paint thinner and paint remover, turpentine, kerosene, those sorts of things. And those are solvents as well. Those are non-polar solvents.